Alright, welcome to another Tech Time Traveler video, and today I've got something I've really wanted for quite a while. Not one, but two Netronics keyboards. Actually, just one is a keyboard, the other is actually a full-blown serial terminal. Netronics was a popular electronics kit maker back in the late 70s. One of their first forays into computers was their ELF 2 kit, a project that greatly expanded the original popular electronics ELF concept into something approaching more like a full-blown computer. Later on, Netronics also developed an Intel 8085 based computer called the Netronics Explorer 85. There was also a rumored Explorer 88 that was supposed to be PC compatible, but I've never actually seen pictures of one or anything, so I'm not actually sure if it was ever produced. Netronics, like a lot of companies at the time, licensed Microsoft Basic for its users, which made both computers, but especially the ELF 2, a whole lot more usable. However, neither computer was designed with direct video output or keyboard input in mind, so both machines relied on serial communications, and so you needed a terminal to actually use them. Netronics already made an ASCII keyboard for general hobbyist use, so to accommodate those needing a terminal, they created a single board solution that would mount inside their keyboard case. There were a few different versions of this, but the most common seems to be the FastFid 64, a 64-character capable unit that offers the ability to have custom character sets and graphics characters via EEPROM. Since I already had an ELF 2 and several Explorer 85s, I really wanted to have one of these, but unfortunately these terminals are quite rare these days and they are hotly contested by eBay bidders. To compound matters, the case Netronics used for the terminal setup was also used for just the plain Jane keyboards, so if you're like me and you're looking for a terminal version on eBay, you need to pay close attention to the back of the case. You want to see at least a DB25 and an RCA jack for video, and a power jack. Sometimes the back panel was well marked like this one, but often builders just hack something together, which means it wasn't always labeled. Unfortunately, the only way to be sure you have the terminal version if you're shopping for one of these online is to see if there's a picture of the inside available. Further complicating matters is price. Netronics is one of those companies that doesn't have the massive fan base of, say, Apple, but they do have a devoted following and any of their products will tend to fetch hundreds of dollars on eBay, assuming you can find them. A typical Netronics keyboard by itself will go for upwards of $300 sometimes, owing to its tie-in with the ELF community in particular. I actually already have a FastFid terminal and Netronics keyboard as part of that homebrew Z80 system I showed off recently. I'd been thinking about wiring up my Z80 computer so I could use the terminal for other computers, but then I saw this auction for these two keyboards offered as a lot. To my surprise, I actually won. Frankly, I'm kind of amazed I managed to win one, let alone two of them, both the terminal and the non-terminal versions. When the timer ran out, the eBay app on my phone said I'd lost, but then a day later I got a notice to pay up, so that's kind of cool. The price came in a fair bit below what I've seen individual keyboards sell for if you divide it by two, so that was kind of nice too. Anyway, let's check these out for a bit. First up, the terminal. Looking outside, we can see the Netronics keyboard, of course. These are reasonably high quality units. The key switches they use, whomever's they are really solid and they produce a pleasing clatter as you type. They don't feel loose or squishy like some other hobbyist keyboards of this vintage. This keyboard has a few sticky keys and it looks like the switch mechanism is broken down. I'm not sure if that's easily repairable. I may just have to live with that for now until I can research it a bit more. There's also a decent array of ports on the back here. We've got a printer, serial, video, and this auxiliary connector. Not sure what that does. And of course power. The FastFid terminal is inside the case here. It was designed to go with this keyboard and has holes drilled that allow it to be mounted like this, sort of piggybacked to the keyboard PCB. Overall, the condition of the PCB is excellent, way better than I expected given the condition of the case exterior. Yeah, this cap is loose. That can't be good. That means the pads may have broken off on the other side. Hopefully I can fix that. The other keyboard appears to be just the ASCII keyboard by itself. It's not in great condition, definitely looks like it's suffered even worse than the first keyboard in terms of moisture. It's got a bit more character. I'm not sure what this half calculator thing is for. Kind of reminds me of Doc Brown's hacked up DeLorean dash. Was this part of a time experiment? I set the machine to 2022. I just thought it'd be cool to get a glimpse of our happy post-you-know-what world. Yeah, looks like things are back to normal, alright. Now for some year-old taco leftovers. And I love the note here on the bottom. Yeah, because that's totally not going to cause people to do the complete opposite. It looks like this unit was used in some kind of business or educational environment. And then it has this really long ribbon cable with a custom adapter that I've never seen before. I don't know if I'd have much use for this at the moment, although I can find a period correct project needing a keyboard like this somewhere, I suppose. Anyway, for the purposes of this video, I think I'm going to try fixing up this Netronics terminal keyboard, as this is something I've really wanted for a long time and that goes with my other Netronics equipment, and it'll give us more eye candy than just the keyboard will. Anyway, let's open it up here and see what needs doing. So the first thing I'll note is that we have 4 pads here for power. Plus 8 volts, minus 16 volts, ground, and a pad marked AC. You might be wondering why an AC connector is in there. Well, Netronics were pretty flexible when it came to providing their customers with options. Looking at the manual here, we can see they provided several options to connect either a DC power supply that you supplied, or one that they offered, or an AC power supply if you installed some additional parts, including that large gray loose cap that I showed earlier. I'm a bit more used to working with DC power supplies for my equipment. It just seems to have been the more popular option. But I'm told AC does have some advantages, namely that it doesn't care about polarity and is easier to adapt to 110 volts or 220 or 240 volts or whatever your input power is. Since this terminal is wired up for AC, that means I'm going to have to dig through my parts bin of orphaned power cords and see what I can come up with that does that. So how does this thing work? Well, absent a schematic, which I couldn't find anywhere at the moment, it looks like we have the circuitry that generates the actual video over here, some screen memory here, a UART for serial communications, and then what I suspect is a custom PROM that is actually the engine of this whole thing. The FastFit is a decent little terminal board. It can communicate via serial or TTY for devices that were designed for teletype use, up to 19.2K baud if using serial. It can do normal or reverse characters also. That's not bad at all. And it has 2 sockets for custom programmable EEPROMs, 1 socket for text and 1 for graphics. So that makes this thing very configurable for a whole variety of tasks. You might recall how I ran into an issue with this on my Z80 homebrew machine, chiefly that the text EEPROM had been installed in the graphics ROM socket, which required hitting Control-A to actually see text when you first started the terminal up. I don't know why it was done that way, but that was the only way it would work, so I left it as such. Well, I guess the first thing we can do here is a nice surface clean. For this sort of thing, I generally just use a microfiber cloth dampened with water. I do use cleaners like Windex sometimes, but I find water to be the least harsh, and microfiber is really good at scrubbing off dirt and scale. I must confess, although I don't like the feel of the microfiber cloth on my hand, they are quite a miraculous little invention. Anyway, let's scrub off this rust as best we can, and we'll see what we're left with. And yeah, rust does tend to come back, but this keyboard will be kept in a dry environment from now on, so hopefully it'll be really slow if it does at all. Anyway, let's borrow the other keyboard and we'll just travel into the future here. Okay, so now we got to do the keys themselves. I can't just clean up the metal and leave the keys all gross like this. And this is where I really wish I had a proper key puller. These ones are stuck like they're glued on. Anyway, some heavy duty wiping will clean these right up. A little more time travel, please. Yeah, much better. Wow, it's amazing what a little elbow grease does. The surface rust I've cleaned off may well return, of course, but I'm hoping with better storage conditions it won't happen too quickly. Like I said, I'm really reluctant to remove the original paint and do any kind of repainting. I hate doing that. But at least the keys aren't covered in goo anymore. Alright, let's take a look at the electronics now and see if I can repair the broken cap and fix anything else that needs fixing. Then hopefully I can scrounge up an 8 to 10 volt AC adapter and try powering this thing up. Alright, so it looks like the solder failed, but it didn't take the pads with it, so this should be an easy fix. And voila, everything is solid again. No idea how this happened in the first place. It must have been a really weak solder job or something combined with being bounced around. In a previous video about the homebrew Z80 machine I had that used one of these terminals for its input-output, I mentioned that this version of the FastVid board has two sockets, one for text and one for graphics characters, and on mine the owner for some reason had that reversed. Anyway, this one has both sockets filled, so that means we possibly got graphics characters in addition to text here. That'd be kinda neat. Now, as always when dealing with EEPROMs, I think it makes sense to dump these before I even think about hooking up power. So I'll just remove this one. Whoa! Yeah, that was really stuck in there good. Oops. Okay, so we'll dump it and we'll see what we've got here. Thankfully it's a 2716, which is just new enough to work with this reader. Okay, that's interesting. I'm used to seeing EEPROMs filled with data from the very first address, but here it looks like the data doesn't start until a ways in. I don't know if that's on purpose. I guess it must be. It's either that or we've got bit rot going on, and that's always a possibility with stuff this old. I'm not seeing any recognizable characters on the right, so this is possibly the graphics ROM. I'll save it here anyway. I don't think anything here would necessarily be replaceable, but it's nice to have. Now let's check out the other one. Man, these things are almost welded in place. It's like the chips are too wide for the sockets. Alright, so dumping this one we can clearly see some recognizable characters on the right, and again it seems to start around the same place, so yeah, I'm thinking this must be by design. I'll save this anyway. So now for power. With the FastVid board there are two options for powering it as I mentioned. You can use either AC or DC power for input, attached to these points on the left. On this particular machine they've opted to go with AC. As I mentioned earlier, AC has certain advantages, and anyway, this is how they set it up, so unless I want to go removing the AC power supply parts, I'm just going to have to find a supply that'll work. The fact that one terminal was marked AC and the other ground sort of threw me, because I'm used to thinking in terms of polarity, but I understand from others that the ground is more for the benefit of using DC power, and that with an AC adapter, it shouldn't matter which of the two wires from the standard wall wart should go where, as long as they don't get connected to the DC inputs. Now, I was a little bit concerned about sticking with AC because this keyboard obviously didn't come with its original power supply, and AC power supplies are not something I have a lot of, and most of the ones that I have tend to be the wrong voltage. But that said, I did manage to find this one from an old Creative speaker amp, and it puts out 10 volts AC, which is just at the limit for input according to the back of the case here. So the port on the back of the keyboard accepts a 3.5mm plug, but I don't have one of those handy at the moment. So what I'm going to do is I'm just going to cut off the barrel plug here and then strip the two wires and solder to the appropriate points on the board. Interestingly, one of these two wires has a stripe on it. I'm not really sure why, but I'll stick it on the AC side of the board here. Now, before we go plugging and praying here, I'm just going to remove all the ICs carefully and set them aside. Thankfully, Netronics favored sockets and sent them along with their kits, and that makes it a lot easier for me 40 plus years later to actually take things apart and test ICs to see which are working and not. For now, I just want all the ICs out so that I can test that this thing is producing good, clean DC power to the right pins and make sure it doesn't, go on fire or something. And yes, I'm placing all the ICs in a specific order so that I can avoid losing track of what goes where and then very easily reinstall them.
I'm not a moron, you know.
Okay, so now that they're out, I'm going to spin this around the solder. Oops! Well, so much for that plan.
What a moron.
Good thing I took lots of pictures beforehand. Always take pictures before you disassemble anything electronic. Lots of pictures. You can't even really just trust the parts placement guide from a manual because sometimes people go off script or make modifications and you may reinstall a part that you think belongs there but the owner changed for some reason. Okay, so we'll solder our 2 wires here from the AC adapter. Alright, time for the big test. Let's plug in and hope nothing burns. Drum roll, please. Nice, no fire. Alright, so nothing smoked, nothing got hot. It's time to power up and do some testing with my multimeter here and just see that we're getting the right voltage. Yep, pretty much 5 volts DC on the nose. That's awesome. Now, one thing I'm not sure about here, I've been looking at the data sheets for all the ICs and I'm not seeing anything that uses anything other than plus 5 volts. So why does the FastFid board have DC inputs for minus 16? That would usually imply that they were trying to get down to minus 12 volts or something, which is commonly needed for serial I/O. But yeah, this board doesn't seem to have the need for that at all. Weird. Alright, with the help of some pictures, let's plug the chips in again and once again say a prayer to the digital gods that everything is as good as it looks. Yeah, this doesn't look too promising. It's not responding at all to any key presses. This isn't the way it works on my other FastFid terminal, the one that's installed in my Z80 machine. Let's try the old power on, power off trick. This looks a bit more like it. We've got some random characters down below, but that's probably normal. More importantly, we've got a blinking cursor up top. The fact that we've got clearly identifiable characters down here tells me that the main character generator EEPROM is probably okay, and the blinking cursor suggests the control PROM is good also. Doesn't seem to be doing anything, but I wonder if it needs something to loop back from. Okay, let's see if anything actually is happening here. Remember my good friend Mr. Breakout Box? Yeah, I know he doesn't look much like a box, but he does the job just fine. I've got it hooked up to a serial cable here, and what I'm going to do now is power up the terminal and try typing, just to see if anything is actually getting sent out. So here we go. Okay, that's not quite right. Normally when you type something on a serial terminal with a breakout box connected, you'll see the TX or send LED very briefly light up and then go out. Basically, that's whatever you typed being shot out of the UART. But in this case, the light's staying lit and it's operating more like a weird light switch, only going on and off whenever I press a key. That's not right at all. Okay, so perhaps something is going astray because we're not actually connected to something. You never know with these old obscure terminals. They're all a little different and they all require slightly different connections to actually work. What I've done here is I've looped back the TX line to the RX line so that the terminal essentially sends whatever I type back to itself by way of the breakout box, sort of like having a local echo. But as you can see here as I type, yeah, it's totally getting stuck still and we're still not seeing anything coming up on screen. So this isn't normal at all. In this situation, I'm kind of suspicious of the UART. I've had a few terminals arrive with dead UARTs before, and that seems to be a common point of failure. It could well be a transistor or IC down the line also, and another thing that it would often be are the chips that are used to basically amplify the signal, like the MC1488 and 1489. Those very commonly failed, but we don't have those here, so yeah, I'm kind of looking at the UART right now. And anyway, since I have a working FastFid terminal of the exact same type to borrow parts from, and since the UART is socketed, I might as well just borrow from my working terminal and test quickly. And let's power up, and we'll press some keys. Yeah, that's more like it. It's actually very hard to see on camera here because A, it's very fast, and B, I'm a moron who doesn't know how to film things properly yet. But that TX light is definitely blinking on and off very quickly with a single key press. So yeah, that old UART must be dead. Okay, so now I'll try crossing the TX and RX line to see if the terminal will echo back stuff that I type. Nope. But you can see more clearly the blinking as the information I'm typing is being passed from the TX to RX lines. So I think the lack of characters appearing could be something else going on, or it could just be that I need to jumper other pins like CSR and DSR to the terminal so that it knows that it's good to receive data. Well, what better way to test things out than to bring out this FastFid terminal's stablemate, the Netronics Explorer 85. Ooh, shiny, blue. I love this thing. You might recall me talking about the Explorer 85 in my previous unbuilt kits video. I actually have 3 of these things now, a totally unbuilt kit, a level A single board unit designed to work with a hex keypad, and then this. This machine I think would be considered a level C. It's based on the Intel 8085 and has a meager 4 kilobytes of RAM, although that is expandable. The thing I love though is the matching blue and black Netronics case. Seeing a picture of this case many years ago put me on the hunt for the Explorer 85 in the first place. But I never saw one for sale until just a few months ago, and it was this one. This one had a buy it now, and I didn't hesitate given how rare they are. The only thing my unit is missing is the internal S100 expansion chassis that gives about a half dozen or so more S100 slots, but otherwise it's the top dog. It has the integrated Netronics AP1 power supply, a nice finger-chopping 12-volt fan, and of course the computer itself, which in this iteration has BASIC and ROM. Or rather should. We have some issues there. But yeah, this thing looks just awesome, and together with the also blue and black FastFid terminal, yeah, what an aesthetically pleasing pair. Sometimes it's just meant to be. Anyway, let's get it all hooked up here and see what happens. Okay, yeah, not much. So normally what's supposed to happen is you power up the computer and the terminal and then you hit the spacebar. The Intel 8085 has built-in serial communications and can detect the baud rate of the terminal attached. All you usually have to do is just hit the spacebar and then it will make the connection, figure out the baud rate, and then display the Netronics Explorer monitor prompt. But yeah, that doesn't seem to be happening here. We do have some sticky keys like this return key, which may not be helping matters. Maybe the spacebar is not working? We have to remember how much surface rust there was on this keyboard before I cleaned it. Well, the rule of thumb with rust is if you can see it on the outside, it's probably all over inside too. So yeah, accounting for possible dead or flaky key switches here, I'm going to try hitting the spacebar a little harder. Ah, bingo. Well, we have some text anyway. Nothing usable, but at least the terminal is reacting to key presses and something's getting sent back. I know for certain the computer is working. I've used it with my Hazeltine terminal. It works just like a charm, apart from the basic ROMs not working. Typically, if you have a serial device connected and are getting some but not the correct response, it can come down to a few things, either a problem with the serial circuit, a baud rate mismatch, or some sort of cabling problem. I don't think it's a serial circuit problem, although it's not a big deal to borrow more chips from the working terminal just to verify. I definitely don't think it's a baud rate mismatch because the Explorer 85, as I said, is supposed to set that automatically. Cable is a possibility, but the fact that we're seeing any response at all indicates to me that we don't have something like RX and TX crossing over incorrectly, and it's not like the terminal's sitting there waiting for a dataset ready signal or something either. I think I should maybe hook this up to something more modern and that I can control more easily and just see what exactly is being sent out by the terminal first. To do that, I'm going to drag out my ThinkPad 380XD here with HyperTerminal, and then I'm going to set it to 9600 baud since that's what the terminal is currently set to. I will also have to change to a different cable, a null modem cable with a 9-pin end on it, because that's what the laptop accepts. Now we'll just set up the HyperTerm parameters here, and we'll type a little test message, and okay, well that's interesting. HyperTerminal is receiving key presses, and initially they look okay, but then it starts falling apart as you type. That's kind of weird. I wonder, let me try setting the terminal to 7-bit ASCII input rather than 8. And yeah, I'm going to apologize here. When I set up this scene, I didn't realize the camera had a different focus mode and it wasn't really capturing what was on the laptop screen, so my lazy effort to just zoom in on that isn't going to work quite as well as I'd hoped. So yeah, I'm thinking this indicates probably an issue with the cable I was using earlier. The Explorer seemed to be responding to my keystrokes. It wouldn't even be able to do that if it didn't get the correct spacebar code at the beginning. So I'm going to dig up another 25-pin to 25-pin serial cable here and try this again. Still have some issues with stability here. Every now and again when I power up I don't get the blinking cursor, just these blocks. Also the spacebar, yeah, the key switch must be going bad. You've really got to hammer the spacebar to get it. Man, it's being stubborn. The worst part is not knowing if it's the spacebar or just the terminal having flaked out again. Finally! Okay, so this is better, kind of. We've kind of got a recognizable prompt here, but we're not getting all of it. The initial Netronics prompt should be about 4 or 5 lines with the copyright dates and so forth. But here we've only got the last line. It's overwriting the line instead of line feeding for some reason, so why is it doing that? I'll try a command anyway and see if the computer is responding properly. Yep, yeah, this is a memory dump, so yeah, the computer's doing it. This should be scrolling endlessly down the screen though, and instead it looks like the machine is continuously reusing the same line. It's just not interpreting line feeds at all. Oh, well, it did it there. What the heck? This is weird. Okay, so it doesn't seem to be responding to control key sequences either. Is that the terminal or another bad key? Between the flaky power-ups and the lack of response to control characters, I finally decided that I needed a schematic. Problem was, nobody seemed to have one scanned in anywhere. Like I said, these terminals are a little uncommon. So I reached out to a mailing list online for the COSMAC ELF. I had seen Netronics stuff posted there, as Netronics did have a lot of tie-ins with the ELF, and knowing that this terminal had been used with their ELF 2 product, I figured maybe somebody had a manual from back in the day. Sure enough, a kind fellow named Doug emailed back, and not only did he supply the correct schematic for my version of the FastFid board, he also supplied the assembly guide and the parts layout diagram. Thank you so much, Doug. You're a lifesaver. So with this schematic, I can see my hunch about how things worked was more or less correct. The keyboard basically seems to input directly to the UART, and the UART doesn't seem very far removed from the serial in and out. A 74393 helps control baud rate via a series of dip switches, and yeah, the PROM pretty much contains the basic engine that drives this whole thing, along with a CRT controller and support chips that help establish a stable picture. It's really not that complicated. Oh, and I discovered why the minus 16 volts is required on the board here. It's not for the terminal board itself, it's actually to be passed through to the keyboard, which has some ICs that require minus 12. A lot of ASCII keyboards back in the day required minus 12 or plus 12 voltages for the keyboard controller ICs. Thanks to the manual, I've also confirmed that the FastFid terminal has a few jumpers on the board for various settings. For example, this jumper determines which control key activates graphics. You can actually use a few, and yep, mine is set up for Control A just like the other one I have, so that should be working. There are also sequences provided for page up, clearing lines, and so on, none of which seem to be working here. Anyway, I thought I'd try swapping some chips with my good FastFid board just to see if I could improve the behavior a little bit, but yeah, nothing changed. I had a theory that maybe a bad 393 was giving me a hard time with accurate serial input, but nope, it stayed the same no matter what I did. I even swapped the PROM to no effect at all. I began to suspect that probably my control key was shot, and yeah, a quick check with my DMM here confirms it's not working. So that sort of explains that. For a few days I puzzled over this situation though with the line feed. Not having line feed is a major problem with a terminal, especially when you have a blizzard of data coming at you. Anyway, while looking over the manual again for something else, I stumbled on this line right here, right above the ASCII code table. Note, the time to execute the above control functions is listed just below the function. Your software must allow sufficient time between commands. If no software delays are possible, you should not operate above 1200 baud. This will ensure that the data to be displayed is displayed. Could that be it? Oh man. And I thought of that too. I actually switched the terminal down to its lowest speed setting and tried it out, but at the time I was unaware that the spacebar was having issues and assumed it wouldn't work at that speed. So yeah, almost had it. I've made a few wrong assumptions here, the biggest one being that Netronics would have set up the Explorer 85 to work at its highest speed with their own terminal. Let's see what happens when we change to 1200 baud like the manual suggests. Man, that sucks. Yep, that's all it was. So for you viewers, yeah, it only took me a few minutes to sort this out, but in real life it took me days to catch this little tidbit. I tried all kinds of things to solve my line feed problem without success. Okay. Well, if you're an expired Netronics terminal owner and can't figure out why line feed doesn't work, let this be your lesson. Always read the manual, assuming you can find one. And you will, because I'm going to post this one online so that everybody has access to it. Anyway, read the manual several times, and then again for good measure. So regarding these problematic key switches, I decided to desolder one and have a look at it to see if it could be taken apart and if the contacts could be cleaned.
Yeah, so this key switch, I'm told they're made by Stackpole, but unlike the key switches that are found in my SWIT PC gear, these are pretty much completely non-serviceable. I don't think the plunger comes out. I don't see anywhere where the plastic is separated where you could pop it apart. So I think these were just built and sealed, and yeah, they weren't expecting you to be still trying to use them 40 years later. So I have had thoughts of maybe drilling a hole, putting some deoxit in there and seeing if that helps matters. I've heard deoxit is pretty amazing. Unfortunately, it's not very common up here in Canada, so yeah, I have to find it. And it's also very expensive. I think it's like 40 bucks a bottle, which is a little bit nuts. But yeah, compared to finding the replacements for these, guess I don't have much of a choice.
I talked to others on various user groups, and it seems like, yeah, the only quote-unquote fix for this is to replace the key switch with one scavenged from another keyboard. So naturally I thought about my really rusty second keyboard here, which I'd been assuming all along was just another Netronics unit, minus the terminal. I figured most of the key switches on it were probably in bad shape anyway, so I figured I'd just scavenge a few of the good ones from it and then make the terminal actually usable again. But
that is not the same PCB. And in fact, if we look very, very closely, it's kind of hard to see there, but you can see the reverse of model 756. And that means that this is not a Netronics keyboard at all. This is a George Risk keyboard. This is a model 756, which is a very, very well-regarded hobbyist keyboard that was produced for quite some time. Very reliable, great keyboard, but not a Netronics keyboard, and does not use the same key switches. So yeah, I thought I was getting two Netronics keyboards, but I unwittingly bought a second George Risk keyboard. I already have one in my collection. So this is going to be number 2. And I guess they just bought a case that mimicked the Netronics one, or they bought a case from Netronics and they just stuck the George Risk in there because, I mean, they're pretty darn close. It had me fooled. I thought for sure they were the same, you know, just, oh, there's a few keys that are slightly different, but the layout is pretty close to identical. But they're not identical. So, yeah, that leaves me in a bit of a bind. I think all I can really do for now is slap the other one back together and just, you know, try and figure out some way of fixing these. Like I said, maybe I can get some deoxide in there, maybe I can find some clever way to disassemble it and clean the contacts. I don't know. That's going to be another project and another video probably. But yeah, for now I'm just going to reassemble it and try firing it up again and yeah, take it from there.
yeah, I never thought I'd see the day where I'd actually complain about scoring a George Risk keyboard, but here we are. It's funny how the case is the same color as a Netronics unit, and that's what totally fooled me. If I'd looked more carefully, I would have realized that the keytops were substantially different and some were labeled differently, which probably wasn't right. I guess blue and black were a pretty popular combination back in the day with several different manufacturers. I do intend to turn my attention to the Explorer 85's ROM problems and get basic working on it, but for now that's going to be for another video. Yeah, I think it's time to sign off here, and we'll move along to the next project until I can figure out what to do with these broken key switches. Anyway, thanks so much for watching, and we'll see you next time.